I'm also a little intrigued what they're doing with this thermostat wire right here. They're breaking. What are they doing here? That's the high voltage. Wait. Holy majoli, guys. They are running high voltage. That's the 240 volt side of that transformer. They're running 240 through that stat wire. What the heck are these people doing here?
This video is brought to you by Sporlan, quality, integrity, and tradition.
Today we have a service call on this restaurant, and they literally put in 3 service tickets that all 3 ACs are not working. I've probably done work for this location for 5 or 6 years, and I've never once worked on their air conditioners. So I don't doubt that they are going to be extremely dirty, probably have broken belts, that kind of stuff. They don't do routine maintenance. They do have a filter changing company, but that's it. So we're going to go through these guys, open them up, and see what we can find. We have 3 AC units. You have a kitchen, you have a bar, and you have a dining room. We are not gonna focus on the kitchen. We are gonna focus on the dining room and the bar because that's where the customers are. The kitchen staff, you know, we'll get to the kitchen, but we're gonna start with this one right here, and then we'll work our way back. Well, might just be an easy one. Open this guy up, and it's hard for you guys to see this. I thought that was a spider falling down, but it says smoke. So smoke detector's tripped. So they're probably all interlinked together. Let's see right here. Yeah, this guy's got a red light. So let's go see what the other ones say too. This one is the next one down. This one right here says strike 3 on compressor number 3, high pressure. So this one has a high pressure code on compressor number 3. The smoke detector is not tripped on this one. And then this one is saying press this to enter guided setup. It's almost like it lost its programming, but it's running. But it's also vibrating nice and thick. So yeah, that's interesting. This guy is moving. Compressors are running. Let's have a look in here. You can see they've had water leaks. There's a lot of condensation. I think I hear a loose belt. Yeah, belt's vibrating pretty good. All right, well, it's just gonna be a lot of maintenance and cleaning and digging into that. So we need to go over here. I think we'll just start with checking belts, filters, all that good stuff. Filters probably aren't gonna be bad, but we need to look and see why this one potentially would have tripped a smoke detector. Open this up. Don't see anything bizarre in here. Does it look like this one lost a bearing? No. No, not really. Blower motor's cold. Don't see any issues there. Let's open this up. Filters don't look too bad. Nothing crazy there. Okay, well, we can try to just reset the smoke detector. We just gotta watch everything. See what happens. Okay, it's reset. And it's not resetting on the board. Oh, there we go. Let's go over here. Indoor blower's running. Sounds like the belt's a little loose, but it's not smoking. Okay. Yeah, I don't see anything that would cause smoke in here. It's odd. Well, we'll let it run for a minute and then check everything out. Looking good here. It's cooling. All 3 compressors pulled in. Let's open these up. All 3 compressors are running. Whether or not they're running properly, we don't know. Condenser fan motors are all running, but this one sounds bad. So yeah, just gonna be a big triage situation. What is this? All right. Went ahead and shut down the first unit. The belt was kind of squeaking a little bit, but it's actually really tight. It's good. This pulley though is going bad. I can feel it, and you can get a groove tool, but I can tell that it's not, it's worn down funny. So we'll put that on a list of things. We'll write down the information. It's a VP50. So you need outside diameter, shaft size, what type of belt's on there, and then you'll be able to, and then single or double groove or triple groove or whatever. So we'll do that. This pulley right here, this has actually got a pretty good wear pattern to it too. So it's probably gonna wear down belts. So we need this one. Let me correct myself for all the crazy people, the sheave and the pulley, okay? But I call these a pulley. This is an adjustable pulley. This is a driven pulley. But anyways, whatever. So, good on that. I thought we were gonna have to change belts, but actually these units don't look in horrible shape as far as cleanliness goes. Metal mesh filters aren't too bad either. So, okay, that's not too bad. Just quickly walking around, this guy started up, so we'll probe up on this and then we'll look in condenser fan motors. So let's go to this next unit right here. This one right here, I can hear a, let's see if we can go over here. I can hear a bad motor. This motor was locked up, I believe, when I heard it running a minute ago. So we'll have to check that. Let's see. Oh yeah. You can see when I spin it, it doesn't free spin. Just kind of locks up. See if I can do this one right here. I'm kind of balancing on this unit. Oh, this one's locked up. No, this one doesn't look like it's locked up, so we'll have to see. We'll try them. And then this one over here, I quickly looked at it and it says press enter to enter setup mode. So I did that and I verified the time. The time was correct. And then now it's saying check 2 amp fuse. Check 2 amp fuse. Interesting is there's a 5 amp fuse there, not a 2 amp fuse. But it's running. So I don't know what the heck. And the 5 amp fuse looks like it's blown, so I'll have to check that. This one, like I said, is vibrating to all heck, but it's running and it's moving heat. But we know this one has a loose belt, so we'll have to check that. So it doesn't seem like it's gonna be too bad here. It just seems like it's gonna be a little cleaning and stuff. So this one right here, again, this is the one that said strike 3 on compressor number 3, high pressure. That's probably because of the fan motor that's locked up. So the first unit is their dining room AC. This one right here, we pulled the blower assembly out because we're gonna go ahead and grease the bearings, because I don't know if they've ever been greased, so we're gonna take care of that. And I'm looking at the duct detector, and as I pull this out, this can cause duct detectors to trip. The thing is completely plugged up with dirt. This is the sampling tube. Let's see. Yeah, we'll rinse that off and clean it. That could be part of the problem as to why the smoke detector's tripping. These detector heads can also get dirty. Oh yeah, there's a bunch of dust in the detector head. So that can be problematic. So we'll clean this guy up, vacuum it out a little bit. So I rinsed and dried this guy off, okay? So you have the inlet ports right there. The way that this works is this is a exhaust right here, okay? It's open. This one right here has a cap down at the end that plugs it off. So what you do is these little holes right here line up with the airstream. So this is the return, right? So the air should be coming into these holes via this way, facing down, and it's forced in through the holes out of this right here. There's a gasket that goes around here that directs the air through the detector sensor and then back out the exhaust port. So we'll put it all back together. I cleaned it up, and then I'll just kind of wipe this stuff down, and then we'll turn it on and see if we get any other issues. Now, things that can cause these to go bad is smoke in the building, bad blower motors, dirty detector heads. There's a lot of different variables there. So grease the bearings, we push that one back in, put the smoke detector back together. Look at that drain. So this guy requires a trap, but they've got a vent right here. So I'm surprised this thing drains. Like, how the heck has this worked this long? So basically, going right there, it's gonna suck air in through here because of the negative air pressure, and it's gonna prevent water from draining properly. Dummies. So we'll cap this off, tape it off for now or something, then we'll talk to them about repairing that drain. That's dumb. I'm probing up on this guy right now. getting Measure Quick all set up, and then we'll turn it on and evaluate the system pressures. All right, let's see what happens. I'm all probed up on a 3-circuit system. So we got, I'm not using discharge pressure, I'm using liquid pressure because Lennox has the liquid pressure ports. Temperature clamps on liquid lines, large pipe clamps on suction lines, temperature clamps on discharge lines. We're probably going to put this unit into a test mode. So we're going to go into service, test, and then now we're in test, and then we're probably going to go down to cool. I know it's hard for you guys to see, and then go over. No, you know what? I messed up. I shouldn't have done that. Go down. What the heck? It doesn't give you the option for full cool. I swear there's... What the heck? Let's see if this one does it. No, this is a weird... They need to do a software update. I bet you there is one. This one will only do 1 stage at a time. That's just dumb. Let's try something else. Let's go back. I know this is miserable for you guys to see, so I'm gonna play with it and see if I can figure it out. Something else, I'm still playing with it, but what I noticed here is, look right here, this minimum outside air position for the economizer damper, you'll run at a certain position for fresh air requirements, right? So it's set for about 15-20%. But notice that there's no OCP light, okay? That damper doesn't open unless the unit knows that it's occupied. You have to run a call from the thermostat to the occupied thing. So there's a couple different methods you can do that. The easiest way is just to run a call from G to OCP, because here in Southern California, we typically run our indoor blower motors the entire time the building is occupied. We don't have humidity, and it's for air balance reasons. So we need to power that OCP terminal. If you power it off of R, it'll never close. Therefore, the outside air damper will stay open even in the wintertime all the time. So we'll definitely correct that, run from G to OCP. That outside air damper is never open for fresh air requirements. Like this is the kind of stuff you find at these restaurants that nobody's thoroughly gone through and done startups or anything on. I'm also a little intrigued what they're doing with this thermostat wire right here. They're breaking. What are they doing here? That's the high voltage. Wait. Holy majoli, guys. They are running high voltage. That's the 240 volt side of that transformer. They're running 240 through that stat wire. What the heck are these people doing here? I'm dumbfounded right now. What the heck? They meant to grab the low voltage side and they grabbed the high voltage side. What the heck is going on? We'll have to see what's going on here. I don't know where that thermostat wire is even going. This is what happens when you have idiots doing startups and installs. They're doing something with this low voltage 18 gauge thermostat wire. Unfortunately, it looks like they were trying to break the transformer, 24 volts, but they're breaking high voltage. So they're literally running high voltage down to something. This unit's been here for 10 years. So I wonder if that's actually energizing something. What the heck are these guys doing here? That's high voltage going through that thermostat wire. Oakley dokley. We are at the first stage right now. Not looking too bad. Pretty decent. Scroll over. Outdoor air is just about 90 degrees. Okay. Not too bad. Supplies 52, return 69. Yeah, you know, it's right there. 17.5 degree temp split. Remember, it's not always 20. It's actually calling for 17 because based on the indoor conditions. So it's not always 20. It's going to range. So we're good on that. Okay. So let's go ahead and scroll back. Not too bad. Let's go to the second stage. Kind of the same. Really nothing scary jumping out at me. All right. Right after that last clip, the whole system shut down, so I had to jump it out real quick. So let's hope. I just turned it back on right now. Third stage, it's kind of looking about the same. Subcooling's about where I'd expect it to be. Nothing too crazy. Everything else seems fine. So we have a decent TD on this guy. All the things are running. What I'm going to do is power it down. Now, I'm going to show you guys a clip of downstairs right now. What I found down there. So I come downstairs and I follow that thermostat wire, and what I'm noticing is they've got another smoke detector down here. So they have redundant smoke detectors. They have 2 of them, which is just dumb. But if we come over here, I have a feeling that they are running that 240 volts down to that smoke detector. Because if we come over here, it's kind of hard to see, but that conduit right there is the 24 volt thermostat wire coming down. It runs over, it goes to the smoke detector and goes right there. So the smoke detector, if it trips, it's breaking the commons or the power 240 volt side on that 18 gauge wire. That is the dumbest thing. And to make matters worse, that is a 15-ton unit, and we have 2 24-inch filter grills on there. That is not enough return for a 15-ton unit, and they're dirty. That's pretty ridiculous. And look at how close the return is to the supply grill. That's just the stuff you see out in the field. So with the return being too small, I mean, it's surviving. You know, the unit's been like this for 11 years. This unit's 11 years old. What they're doing here is I don't know who did this, some dummy, but they're breaking both transformers. So my assumption is that someone wired it up and then it didn't shut the unit down because they were breaking the common of one transformer, right? Because one of these is for the controls, one of them's for the contactors. So had they just, I mean, this isn't the right way, but had they just broken this one, then it would have shut everything down. But regardless, they didn't. They're dum-dums. I want to fix this, but at the same time, I don't know if I want to get involved in this right now. I kind of want to bring this up to the customer and say this needs to be fixed and see if they want me to do it. I think what they're doing is they're using 2 contacts in the duct detector. I can't get up there to see it right now, but just from the looks of it, they're using 2 contactors. They have 2 duct detectors, so that makes sense because when I got here today, this unit was tripped on a smoke detector, but it didn't notify the fire alarm company because the one downstairs is probably wired into the fire alarm. This one's probably not. So this one just shuts down the unit. That one down there just breaks the transformer. But the funny thing is, right here, I mean, it's not even hard. You know, on some of the older Linux units, yeah, there was just a bunch of numbers and you had to find out that terminal 21 was the smoke detector input. But on this one, you literally have power, 24 volts, common for 24 volts, and it's looking at that D1 circuit or DI1. All you got to do is send power to DI1, 24 volts, and the unit shuts down on smoke. Like this, watch. If I just go right here, oh, actually no. If I go right there to right there and I touch that to that, the unit shut down on smoke. You can't see it, but it says smoke right there. That's all that they had to do. But they just don't understand how this thing works because they're silly people, right? So anyways, this guy's really checking out. The last thing I want to do, I'm going to power it down. I want to open up the disconnect, look in here, make sure there's nothing funky going on in there. And then I want to test these capacitors. Oh, and there is a motor over here that's making some funny noise. So I want to look into that. That far motor right there. It's running, but it's making a racket for some reason. So the funny noise on this one is a broken shroud. Look at the shroud right up there. That should be pushed up and it's broken. The tab is broken on it. So, and it's been hitting the blade. So I'm going to recommend that we get a shroud for it, put that back in. We'll put a new blade, possibly a motor, because I don't know what kind of damage has been done by it hitting the shroud. And then we'll have to quote that stuff. So I'm going to probably wrap this one out. We'll quote condenser fan motor, fan blade, shroud, and then I'll test these capacitors, and then we'll do the pulleys, and then we'll see if they want me to dive into this nonsense. I feel like this will be easy to correct. I can literally just delete these, run it to the low voltage side. I can literally wire this guy in to go here. Yeah, no, I can't. I would have to get up into the smoke detectors because this one right here is breaking a circuit. They have it wired to a normally closed contact, and so it opens because of the configuration right here. This setup is looking to make a circuit. So you take R, and when the circuit closes and sends powers to D1, then it shuts the unit down. So I would need to get up into the attic or up into there with a big ladder, grab one of these wires, fix it, and then connected to here properly, and then this guy would have a proper shutdown. So at this stands right now, they'll survive. I mean, it's been like that for 11 years, but I'll bring it to the customer's attention. So I'm gonna take all my probes off. We're gonna check those caps real quick, and then we're gonna turn this guy back on. I couldn't leave it. It was driving me nuts. So what I did was, just temporarily, I still wanna fix it properly, was I rerouted the wires to break the low voltage side, okay? So I made sure there was no voltage. I turned the unit back on with it disconnected, and then rerouted it, connected the high voltage back together. So I still want to give them a quote to go downstairs and properly wire that smoke detector down there up to here, because the alarm is tied into that one. So, you know, you technically want it to be notifying the alarm company when the smoke detector trips. The one up here is redundant, but there's no alarm wiring in. So really what we should do is delete the smoke detector up here and then just wire the one downstairs, you know, unless the alarm company. But anyways, that's a problem for another day. So wired this back up to low voltage where it should be. And that's why I didn't want to get involved in it. I turned it on and it tripped the transformer. So something's going on there. So we're just going to unwire that madness downstairs, leave it disconnected. The unit still has a smoke detector up here. And then we'll have to talk to them about permanently fixing whatever that junk is. All right, I just wire netted those wires off, put them up here. I know I've said I'm done a bunch of times, but I went in and put it back together like that. Now I did wire in the OCP right here like I said I was gonna do. So now we should be opening the outside air damper. Transformer's not tripping anymore. Let's go over here. This outside air damper should be opening up for the first time ever. And it is, you can see it moving. Oh my goodness, outside air. Yeah, and this stuff baffles me, the stuff you can find at these restaurants. Now we just shut off. Why did we shut off? Okay, cool. It's just idle. Didn't trip the transformer. So we just need to go to their thermostat. Their thermostat's not calling or something. Something's going on. Yep, I just had to go to the thermostat. So they're good to go on this one. We'll turn the outside air a little bit more closed. And I'm finally done with this. We'll submit a quote to fix everything else.
So definitely stay tuned for part 2, because I still have to fix the other 2 ACs. It got a little long, so I cut it at that. Now, when I'm approaching these, to be clear also, this video was filmed in August of 2022. Okay, so this was way back in August when it was really hot outside. It's now March 18th of 2023. It's just footage I've been sitting on, just never got to editing it. Sometimes that stuff happens. I have a hard drive full of videos that I need to go through, and sometimes I find ones that are relevant, sometimes they're just nothing, you know, so they just sit there. But these situations do happen, especially with restaurants that don't do normal routine maintenance. This particular one does not do routine maintenance with me. They have a filter changing company that'll come through and like change the filters on the ACs, tighten up the belts. I think they might rinse condensers, but they don't really do much of that. And then also they will clean ice machines and just do other random stuff. But again, they're not technicians. They're just maintenance people. Like, and maintenance people isn't even the right words. And I'm not knocking them. I mean, you know, obviously it's a business and people pay them to do services, but they literally are just guys that change filters. If you guys don't understand that, that's a whole side of our industry where there's people that literally just change filters. That's all they do. Or they get trained on certain tasks. So these particular filter changing companies aren't really trained in ice machine repairs, but yet they are trained on how to clean them. But a good majority of the time, to be fair, the restaurants are paying very low rates, and they negotiate the rates way down to where these guys can't even properly clean the machines because they're being paid pennies compared to what it would cost for me to come in and properly clean the machines. So that's a whole nother conversation for another day. But with these restaurants that don't do routine maintenance, you tend to find this kind of stuff. It's the middle of the summertime. It's August. I get a service call. It's warm in my building, and I go there and I find issues, and it's like, oh my gosh. And I went through the service history of this restaurant because I made a comment in the video that, you know, I don't think I've been here very much. We have done a few small repairs, but it wasn't me that went out there. And some of the more high-level stuff just never got caught. You know, like I think we actually, well, you didn't see it, but again, stay tuned for the part 2. But we've repaired a leak on one unit previously and some other various stuff. But other than that, like, we only have a few service calls on these ACs. Oftentimes I'll go out here and I'll just, you know, big picture the heck out of it, and it's like, oh my gosh, you find all these issues like the smoke detectors, the occupied signal never being energized on the AC. So that AC, the dampers, the only time those dampers were probably ever opened on that AC is when the building balance company came out and did a test and balance on the unit where they set the outside air damper, because that you go into the Prodigy board and you force the dampers open, and they'll still open when there's no occupied signal just for testing reasons, but then nobody actually went through to make sure that the unit would operate properly. That stuff just dumbfounds me, the things you can find. The smoke detector issue. They're running 240 volts through an 18 gauge solid wire. That's just downright dangerous. As I was editing the video, I started thinking about something. You know what it would have been cool? Would have been, and I didn't, but it would have been cool to measure the voltage in the wires that weren't being used in that thermostat wire, right? Because that was like an 18.8 wire, 18.7 wire jacketed thermostat wire, and they were only using 4 of the wires. I bet you anything that there would have been measurable voltage on the other wires in there, just simply because they were running next to the high voltage lines, and the insulation is so thin on those. Is it induction that causes that? I think it might be. I think the term might be induction, induced voltage, when you've got high voltage lines running next to other low voltage lines, and then someone will correct me in the comments, but I'm pretty sure that's what that is. But I bet you anything there would have been measurable voltage, and it almost is an experiment that I'd like to do. Maybe I should rig up a transformer here and do something like that. Hook up 18 gauge wire. Don't ever do this stuff at home, guys, because you could hurt yourself. But anyways, my brain's kind of running right now. But is it induction or is it impedance? I don't know. Anyways, my mind's kind of racing. I'm not an electrical engineer. So, bottom line, we found a lot of problems, and we got the restaurant up and running. Again, you guys will see in part 2, I got the other 2 ACs running too, but that was a whole nother problem. And you guys got a teaser with the transformer, or with the wrong fuse in there. It was a long day, to say the least. Okay. But you know, when you're coming up to these problems, this is why it's so important. You have to understand how these units operate. You really need to, okay? And unfortunately, there's too many people out there that send technicians out that are in way over their heads, and they don't necessarily see these problems. I mean, even I'm guilty of it sometimes. In a bind, I'll send someone out there, just go figure it out, and I'll try to walk them through it over the phone. But if I'm not there to see some of these more complex problems, nobody's going to catch this stuff, you know? And it's kind of bizarre. But for me, like, once I figure something out, it's like I never forget it. So probably I had a situation where I was diagnosing an economizer that wasn't working, and then I realized by looking through the Linux manuals that the economizer dampers will never work unless the unit thinks that it's occupied. Even if it has a call for cooling, it has to be occupied. It's like a weird thing. So I pick up random information. But regardless, again, I keep saying this. Make sure you guys watch part 2. It should be coming out probably later this week. I do appreciate you guys making it to the end of this video. Leave me some feedback down in the comments. Tell me what it's called when you have high voltage lines running next to low voltage lines. And do you guys think I would have had measurable voltage on those other thermostat wires in that line? Like, it would have been minute, but it would have been some sort of measurable voltage. And what is that called? Is it induction? Is it impedance? It's not impedance. I think it's induction. Yeah, I don't know. Anyways, I'm going off. I really appreciate y'all. Thank you very much. Please consider subscribing to the channel. Do me a favor. Check out my website, hvacrvideos.com. We have merchandise available on there. These hats are one of the more common items. We just got a restock of these hats, so we're totally back in stock. Plenty, so help support the channel. Also, if you're interested in supporting the channel, you can do so via PayPal, Patreon, or YouTube channel memberships. There's links in the show notes. You can also support the channel by purchasing tools from TrueTech Tools and using my offer code. So TrueTechTools.com. If you like what they have, I have an offer code, big picture, one word. That will get you an 8% discount on majority of the items on their website. TrueTech Tools has great prices, and they usually have free shipping for orders that are like more than like $50 or something like that. Just go to their website. You guys will figure it out. Use my offer code. You get an 8% discount on majority of the items. I get a small commission from that. It's just another great way to support the channel. Okay? Thank you very much. We will catch y'all on the next one.